So your analogy previously with numbers is actually pretty interesting. Because there's a special, like there are special numbers called primes. There are special knots with each given number of crossings. So here's our trivial knot, for example. Yeah. And how many crossings does the trivial knot have?
0.
0. Okay. And how many knots are there, do you think, with 0 crossings?
Well,
Just
just
this.
the trivial knot, because they would all be the trivial knot, no matter how you orient it.
Okay. Well, now I'm going to show you something. Here's a knot that has 1 crossing.
That can be turned into the trivial knot, though.
How?
And just flip it over. And it becomes the knot with no crossings.
Ah, okay. So do you think my knot that I made with 1 crossing is a new knot? Should I count that as a knot with 1 crossing?
No.
Or not?
You shouldn't.
I
You should
what?
not.
I should not. Okay.
Because this is the trivial knot.
Do you think you could make a knot that has 1 crossing?
No, I don't think so.
Why not?
Because you can always, like, no matter how you do it, you can always seem to just flip it over.
It seems like there's only one way to make a knot with 1
Yeah.
crossing. It's just by basically starting with our trivial knot and then flipping it over.
Part of it over.
And it turns out, it even says here in the book, there are no knots with 1 crossing. Okay. Now I want you to explore knots with 2 crossings. Make something that has 2 crossings.
1, 2.
Okay.
So this definitely, from the way I did it, this can be made back into the trivial knot.
Okay. All right. Why don't you make a knot with 2 crossings that's different than the one your brother just made?
One, 2. So we have tiny crossings.
Okay, there's tiny crossings. What do you think about that?
And it can be turned back into the trivial knot.
Okay. Do you think there's any way to make a knot with 2 crossings?
No, because you flip it back again.
What about 3 crossings? Do you think there's a knot with 3 crossings?
that-
We
the
made
trefoil
one.
knot.
There's, yeah, the trefoil.
Yeah. How do you make the trefoil knot? Can you
So-
turn that into the trefoil knot?
So we're sort of over, under, and then back like this.
All right. So let's see. Is that? Can you untangle that?
Whoops.
Okay.
So I think this is what I made last time, which, yeah.
That one had.
How about this?
Might work.
Did it pop together?
Oh.
Yeah.
Here, let me try. Sometimes it's hard. Sometimes it's hard to get these things, and we just ate breakfast and our hands are a little. There you go.
Let's see if we untangle that.
No.
That is the trefoil.
All right. How many crossings do we have?
We
There's
have
3.
3.
3. Okay. So we have 1 knot with no crossings, and it didn't seem like we had any with 1 or 2. But this is something that seems to be different.
It's the 3 crossings.
It has 3 crossings. And it turns out mathematicians have counted the number of different knots, and you can imagine it gets pretty hard. And so I guess I'll just show the picture from Colin's book. So there's the trefoil. It turns out there's 1 with 4,
Yeah.
And maybe my challenge will be after we turn off the camera, I'll have you guys try to make that one, because that's, you know, sort of the next easiest knot. But there are 2 with 5,
Yep.
3 with 6,
7 was 7.
7 with 7, 21
With 8.
with 28, 49 with 9, somewhere in the oh yeah, it's actually on the next page there's a table, 49, 165 with 10, and you can see there's a little note that they used to think there was 166, and then someone discovered the 2 of them were actually the same. So that's pretty cool, but you can see it gets high pretty fast. Up to 16. How many of them are with 16 present?
Over 1 million.
Over 1 million. And no one knows how many there are with 17
What
crossing.
if there's some sort of pattern?
Well, if there is a pattern, that would, I don't think they know it yet because they don't know how many there are with 17. But if you found a pattern in those numbers, it would be a big breakthrough in math, I think.
Yeah.
All right, so after, with the camera off, I'm going to have you guys try to build that 4 knot crossing. But this is a neat subject, and surprisingly difficult too. But it's really neat, and the geometry of these knots has been a fascinating topic of study for a
Yeah.
long time. But you can also see it's fairly recent. Like when did this 165, 166? What are the dates in there?
1989.
Yeah. Look at
Oh
that.
no, 1899.
1899. Okay, yeah, I didn't think it was that
Yeah.
long ago. But even down here to get to 16, is there a date in here? 1980? Does that say 1981?
1997.
1997.
1998.
So this is all fairly recent stuff that people are learning about.
Yeah.
Anyway, good work, guys, and I'll have you make that knot as the last part of this project.
Okay.
All right, good work today.